Okay, the limit laws are hardly worth writing down for you, but I'm going to write them down because I have to be all fancy and be a teacher. This is why, this is just, you know.
So I'm really glad we're learning how to write and solve equations and inequalities.
Yeah, it's important.
Wish we could do that.
Okay, so let's say we have two functions, f of x and g of x. So they're two different functions, and we want to figure out the limits as x approaches a. And this number here and this number here are the same, okay? So here's some little tricks that we can do, and this is just going to be totally shocking to you when I write this down. The limit as x approaches a of f of x plus g of x equals, this is a stunner, the limit of the first function plus the limit. Well, yeah.
Well, yeah,
I
of
told
course.
you, this isn't even worth writing down. But I have to just like do it anyway. So if you want to find the limit of two functions added together, if you find the limit of the two functions independently first and then add those answers together, that will give you the same answer, okay? If you want to find the limit of two functions that are being subtracted, guess what you do? Then you subtract the two limits.
When it says the limit thing minus the limit thing, then you just subtract it.
Yep, okay, and the same thing holds true with multiplication and division, and if you're multiplying a function by a constant, okay? So that's not, shouldn't be exactly a rocket science, okay? Yeah, earth-shattering discovery there. So, whoa, I guess that's not going to work. All right, so let's do an example of this. Use the limit laws and the graphs of f and g in figure 1 on page 78. We'll be on page 78. There's a little graph there. The red graph is f, and the blue graph is g. Figure out what the limit as x approaches negative 2 of f of x plus 5 g of x is.
Wait.
So you're on page, you should be on page 78.
I see it.
So first of all, what's the limit as x approaches negative 2 of f of x? What's this part right here? 1. Okay. What's the limit of g of x as x approaches negative 2? It's what? Negative 1. And so 5 times that will be negative 5. And so my answer is what? Negative 4. Okay? You guys that are talking in the back of the room, you get that?
Yeah, because you just add them.
How did I find those things to add in the first place?
Plug in negative 2.
Plug in negative 2 to what?
They were talking.
You have to look at the graph. Okay, and if you look at x equals negative 2 and then you go up to the graph, that's where the 1 comes from and that's where the negative 1 comes from. Okay, so that one works out to be negative 4. Okay, what's the answer to B? What's the limit as x approaches 1 of f of x times g of x?
Negative 4.
Negative 4.
Am I wrong?
What's happening?
You can't do it.
You can't do it? What's the limit as f of x approaches 1? 2. Okay. What's the limit as g of x approaches 1?
It's 2 different things.
What's that?
Isn't it 2 different things?
So it doesn't exist, right? Because if you're looking at g, if you approach one from the positive side and if you approach one from the negative side, you get two different answers, right?
Yeah.
So you think since that doesn't work, we're no good? Okay. There are special cases where something funny can happen where this is going to work. So if you say the limit as x approaches 1 of f of x times g of x, and you break it down into the limit of x approaches 1 of f of x times the limit of x approaches 1 of g of x, and then you say that since this doesn't exist, the answer doesn't exist. There are situations where that is not necessarily true, and here's what you have to do to solve this. You have to look at what is the limit as x approaches 1 from this thing of the negative side.
Like that.
What would the answer to that be? This limit is still going to be, the limit as x approaches 1 from both sides is 2, so from the negative side this is 2. What's the limit as g of x approaches 1 from the negative side? Negative 2, and so that gives me an answer of negative 4. What is the limit as x approaches 1 from the positive side of the product of these limits? Okay, this one is still going to be 2, and then this one from the positive side of the limit is what? Negative 1, and so those work out to be negative 2. That works out to be negative 2, right? Okay, since these two things are different, that means the limit does not exist. Okay? But can you imagine in your brain a case where if f of x had two different answers, you could multiply these together and get the same answer? Okay? In that case, the limit would exist. Okay? So you have to be careful with that when you're doing composition of limits like this, when you're doing products and all that kind of stuff. Just because the limit of g of x at that point does not exist, doesn't mean that this limit doesn't exist either. Okay? Because it's possible that I could take the f graph and change this so that this limit would be 4, right? Can you picture that? So if I have 1 right here and I'm approaching from the negative side and I want it to get to 2, but then let's say it had a discontinuity there also, and so it looks like this from the other side. So here's 4 and there's 2, you know what I'm saying? And then this would be negative 4 also, and then the limit would exist.
And same.
Right, so you have to look at the left and right hand limits when you're dealing with products and quotients to make sure that both of them didn't change in such a way to make them equal to make it exist. All right? Okay, so that was fun. All right, how about part C? The limit as x approaches 2. What do we got going there? The limit as x approaches 2 of f of x divided by g of x.
What's the point of this?
What's the what?
Point of like dividing and
Well, the discussion that we just had about products and the right hand and left hand limits is very important.
Oh,
Yeah,
yeah.
well, like, what's the point of doing all that?
Like, what's the point of like,
Adding,
why would you
subtracting.
divide? Yeah.
Well, we just did one. For the other thing, we wanted the limit as x approaches 0 of the tangent of 3x over tangent of 5x, right?
Oh,
And what we just learned is we could do those two limits separately and then divide the answers if we wanted to.
Why would you want
Why would I want to do that?
Algebraic
Because
instead of
if I,
estimating.
right, because if I do the tangent of 3x divided by the tangent of 5x, and this was the limit as x approached 0, right?
Oh,
You
okay.
can just, okay? Now I could just say plug in 0 and let's figure out what the tangent of 3 is, plug in 0, figure out what the tangent of 5 is, and then divide it, and that's my answer. All right? Okay, but anyway, that doesn't get us to the point of this one right here. What's the answer there? Yeah, sorry, and I tried to move it up and some of it moved in the other direction. What's the limit as x approaches 2 of f of x divided by g of x? It's in your book there too, on the bottom of page 78. What is the limit as x approaches 2 of f of x? 1.5, what's the limit as x approaches 2 of g of x? 0. What's 2 divided by 0? No can do, so that means that that limit doesn't exist.
Dang.
Okay? And we could play the right hand, left hand thing, but you can see that it's still going to be a problem. Okay? All right, then there's more unnecessary stuff on page 79. And what page 79 is basically saying is to find the limit as x approaches a number, plug in that number, and that's your answer. Okay? So if you want to find the limit as x approaches a of x to the n, just go a to that power. And so I'm going to do an example right here on the board. And so if you want to figure out the limit as x approaches 5 of all this junk right here, what you really need to do is go 2 times 5 squared minus 3 times 5 plus 4. Right?
But that only works sometimes.
That only works sometimes. But you need to just make sure you understand that as x approaches a number, the limit you're finding is the y value of that function. And the way you find the y value of a function is you just plug in, I'm sorry, Mr. Wayward, you substitute in the value for x. Okay? Is this a 5? Yes, it's not a -5. And so this would be 50 minus 15 plus 4, which would be what? 39? Okay? So don't forget that. You're going to forget that. I'm going to give you an assignment at some point in the future, and it's going to be this crazy limit thing, and you're going to be all, oh, the algebra, what do I do? Can I factor something? Da, da, da. And the answer is no, just plug in 2, and that's your answer. Okay? So always check to see if you can do that first. And then if you have those dividing by 0 issues, then you can't do it, and then we'll do something else fun. Okay? So same thing here. If you just substitute in -2 for the x, you get -8 plus 8 minus 1 over 5 plus 6 is...
You can't do it when the bottom.
You can't do it when the bottom equals 0. Right? But you can with that. Yeah, not a big deal. And they want us to justify all of the steps by referencing which limit law we're using to do that, but we are not going to do that. Okay? Too much. Unnecessary. All right, so let's go back to one that I think we talked about already. Right, so I think we did this problem already when we started talking about limits. Right, difference of 2 squares. And so the first thing that you should try is we just talked about, is just try directly substituting the value into the equation. But in this case, that would give us a divide by 0, which we can't do. And so we can factor out the top because it is Rena's favorite. The difference of 2 squares. Cancel these. Now, what's the answer? 2. Right? Now I can substitute it in directly because I've removed that discontinuity, and so my answer is 2. Okay? Yes. Yes. Sorry. Yeah, so there are kids that go to big schools in Seattle and Tacoma, things like that have super smart kids that start taking algebra in 7th grade. And so it's not uncommon for juniors to be taking calculus in high school these days. What you're studying is called calculus AB. The next course would be calculus BC.
What about like after that?
After that, that depends on what your...
Then you go into different like...
Yeah, you can go in different ranges from there. Calculus is the foundation for all upper level mathematics, and then you can go from there. I took, when I was a sophomore in college, a class called linear algebra. It's really super exciting. I'm looking over there and trying to see if I still have my textbook.
Is that the thing you showed Gonzo? That was...
Okay, so you can do limits with piecewise functions too. So if we want to find the limit as x approaches -1 of g of x, then what are we doing here? Oh, so this is a very strange function that for some reason they decided to make a straight line. So this is x plus 1. So it would be a straight line. Why would you say straight line? A line with the y-intercept of 1 and a slope of 1. And then they decided, hey, everywhere except for at x equals 1, it's going to be a regular old function. But where x equals 1, we're going to, for some reason, make the value of the function be pi. Okay? Just because we just want to make you angry. Okay? So what is the answer?
-1 is
Which is -1.
Oh, I wrote the wrong thing in the notes. In the book, it's x approaches 1, but that's okay. Yeah, so what do you have to do? What's the answer? What you said? It's 0, right? Because you just take x equals -1 and plug it into the function, because this will work right here. The point they wanted to make, though, is they wanted the limit as x approaches +1. What would that answer be?
Wouldn't it be 2?
It would be 2. Okay, this is the value of the function at that point, but when we're talking about the limit, we just want to know the y value that's getting closer and closer to from both sides. What's that? Yeah, you just substituted it in there and you get the thing. They were trying to trick you and I wrote it down wrong, so that made it even worse. All right, how about this? Evaluate the limit as h approaches 0 of this stuff here. What's that? Definitely can't just do it by substitution, so what are you going to do?
You can play your
Foil.
Okay, let's FOIL this out. And so what we're doing here when we're FOILing this out is we're kind of using the limit laws that we just developed, but they're so obvious that it's not what's really worth doing. But that's technically what's going on. Okay, so if I FOIL that out, I get 9 plus 6h plus h squared minus 1 over h. The way you FOIL in your head is you square the first one, right? You multiply these together and then double it, and then you square the second one. You need to get pretty quick about that. Square the first one, multiply them together, double it, square the second one. Okay, so what can I do now? Cancel out the 9. So you've seen this game before. And let's do our math correctly. What can I do on the top here? Factor out an h. And then once I have factored out that h, I can cancel these. That allows me to substitute 0 in there directly. And so I find that my answer is 6. Okay? So we've kind of gone through a lot of this before. We're just doing it in a little more formal way right now. Okay? Waiting. What are you confused about? Because I plugged in 0 for it.
Where?
At the football game.
Who was?
He was with these 2 boys.
Who was he?
Gordon was. He's with Nathan and then like 3 boys I didn't know. They're all in football houses. Because they're college boys. They're grade 2 college students have been.
Okay, I feel like we've done this one before also.
We have.
They have two good hang out with.
So do you want to run through this again, or do you, just for fun? So what am I going to multiply the top and the bottom by?
The opposite, the conjugate.
Right, the complex conjugate. Okay, so when I do this, when I'm FOILing this out.
Okay, John's rules in
I was
effect.
talking to Evan.
Okay, well, we've done this one before.
I know, but I just need to remember.
Sure.
Patricia's in the marketing class. You brought in a cereal box.
Okay, so if I FOIL this out, first times the first, the square roots cancel, right? And the negative, I'm going to go ahead and run through and get negative t squared minus 9. Then, as I mentioned before when we've done this, the reason why we chose the opposite here is because negative 3 times that negative square root will give me positive 3 times that. Negative 3 times that square root gives me negative. So those cancel. And then negative 9, or negative 3 times negative 3 is positive 9. And then as I tried to emphasize before, do not try to distribute on the bottom. Leave that the way it is. Right, because the 9s will now cancel, and then the t squared there and the t squared there also cancel. So that gives me negative 1 over negative square root of t squared plus 9 minus 3. We want the limit here as t approaches 0, so what can I do now? I can substitute 0 in there for the variable. Square root of negative 1 over negative 6, which is 1/6, which is what we got when we did this before, and we were looking at the graph in the table, and it was approaching 0.16. Okay, do you recall? So maybe we got ahead of ourselves before. I'm not sure why these are coming up again. All right, absolute value is an absolute beast. What you need to do with absolute value in order to do limits is you need to break it down into a piecewise function. So you want to say that the absolute value of x is the same as saying that f of x equals x when x is greater than 0, and negative x when x is less than 0. When there needs to be an equal to on one of these, it doesn't matter which one you choose, okay? So what you're doing is you're taking the absolute value function, which you remember is a V-shaped graph, and you're saying this is the same as the graph of y equals negative x. This is the same as the graph of y equals x. You're breaking it down in 2 ways. What's that? Yeah, so it doesn't matter which one of those is equal to 0. So the way that we're going to show that the limit is equal to 0 is we're going to now look at the limit as x approaches 0 from the positive side. And we're going to look at the limit as x approaches 0 from the negative side. Okay? Because those you can do by substituting it directly into this piecewise function. Okay? Well, you could kind of, but like I said, the idea here is to get you into the habit of thinking of absolute value functions as being 2 separate functions. But that's what you're going to have to do later on. So if I take and figure out the limit as x approaches 0 from the positive side, this is the positive side. That's where x is greater than 0, right? So if I plug 0 into there, I get 0 as an answer. If I find the limit as x approaches 0 from the negative side, that's these values down here. This time I get negative 0. And since those are different, the limit doesn't. They're both 0. So since the left-hand and right-hand limits are both 0, that means the overall limit is 0 compared to, okay? How about the limit as x approaches 0 of the absolute value of x divided by x? So we need to do this in 2 different ways. We need to do the limit as x approaches 0 from the positive side, and we need to do the limit as x approaches 0 from the negative side. What is this function become if I'm only looking at positive values of x?
I don't know.
Linear.
What? Is it y equals x or y equals negative x when it's positive values?
X.
Positive value, so this would be x over x. So I'm rewriting this as just plain old x, because if the numbers are positive, I don't have to take the absolute value. What does the absolute value function become if I'm looking at the negative numbers, right? So this one would be negative x over x, okay? Cannot plug 0 in, but what happens to these 2 x's? They cancel, give me an answer of 1. What happens to these 2 answers? They cancel and give me an answer of negative 1. They're different, so the limit does not exist. Okay, and you could confirm that by looking at the graph of the absolute value of x over x on your calculator if you want to. Okay? All right, so sadly we're out of time. I have a couple more examples to do in this section. Do you want me to put the assignment on the board that you're going to get tomorrow?
Yeah.
So that you can start it tonight if you want? Yeah, you might not start it, but I know that there's some people that like to get a jump on things. So you might come across problems on this assignment that you will not have the skills to do right now. We will learn the rest of that stuff tomorrow. Is this 2.3? So this is page 84.